Hello, Scholar. It's me. Welcome back, or welcome if you're joining me for the first time. I promised a video on apparent volume of distribution, and here is a video on apparent volume of distribution. If my voice sounds weird, I'm not feeling fine. So, in pharmacokinetics, the calculation you do doesn't really follow your anatomy. And for pharmacology, we have a big problem with the body. The thing is, we can't really start tracking each organ to see how the drug enters each organ. So the only sample we can get is your blood. It's the only way we can know, oh, this is what the drug is doing. So, because of that, we have to estimate things using your blood plasma. And that is the exact problem we have with apparent volume of distribution. Apparent volume of distribution, or VD, is the theoretical volume of fluid that would be required to contain the total amount of drug in the body if it were to be distributed at the same concentration observed in plasma. So this is the formula. VD equals the total amount of drug all over the plasma concentration. Now, this flask in a box analogy basically shows what we are doing with VD. You have a flask in a box, so you don't know the volume, but you took a sample of a liquid in that box after adding dye to it. Now, you took a sample and you found out that the concentration of the dye is, let's say, 50 milligram per liter, and you know the amount of dye you placed in that flask. Let's say you placed 1000 milligram of dye. So you do calculation and you find that, oh, the volume of this fluid, or the volume of the flask, or the volume of the fluid inside the flask is around 20 liters. That's basically what we're doing with VD. So we'll come back to this analogy in a bit. Like I said before, we use the blood to know what a drug is doing. Now, what happens if this drug doesn't stay in the plasma? Think of it. Just a quick reminder of the body's total body fluid compartments. Plasma contains 4 liters, the interstitial fluid contains 10 liters, then the intracellular fluid contains 28 liters. So in total, you have 42 liters of total body water. So VD tells you where the drugs likes to stay. Drugs with low VD, like heparin, which are highly plasma protein bound, love to stay in the plasma. Drug with medium VD, like gentamicin, they like to stay in the ECF, which is between plasma and interstitial fluid. And drugs with high VD like to stay in the cell water. So drugs like phenytoin, ethanol, these drugs like to stay in the cell. So they cover the total body water.